Welcome back, everybody. So here we are back in our bookmark feature where we left off here. And we left off with some technical requirements, some high-level technical requirements, along with some questions based on a set of designs for a bookmark feature that we have here. And these are just some kind of rough sketches of what those designs look like. So what we're going to get into now is the next phase. As a developer, you come into this story, you read our business use case up top here, you kind of see all the requirements. Let's envision that these questions now have gone off to the designer, but we're in a time crunch here, so we have to get started. We can't just stop work to wait for the next step. There's usually things we can begin doing with the information we have here. Now, where do we start? Do we start building the front end, or do we start building the back end or the database architecture of this feature? I think that's going to change developer to developer. Some people prefer to start by building out the front end components, and some people prefer to kind of start at the database and build the foundation up from there. I think it kind of depends on comfort level. If you started off as a front-end developer, you probably feel more comfortable kind of laying the design out and using that as the vehicle by which you're going to think about the back end. And if you maybe start as a back-end developer, that might be your comfort zone. For me, though I started as a front-end developer many years ago, I think for me, I do still tend to prefer to start on the back end, getting the database architecture, building the API endpoints, and then powering the component from there, just because I prefer not to work off of like mock data on the front end or something like that while I build it out. So that's just my personal preference. So that's where I'll start. I do recommend the database layer, giving some thought to that first. Not necessary, just because what ends up happening is I think that after you kind of lay that out, it's a little bit harder to change if you've made a poor choice in database design or data design. But either way, what I'd like to start with is really not in the code. Again, I'm very big on this. Before we even write any code, I like, as a developer, to get some thoughts down on paper about how I'm going to design this database. So let's begin here with another square below here. And let's imagine this is sort of like potentially a comment in the ticket, something of that nature. I'm a pen and paper person. We're going to use Excalidraw just for the purposes of this demo. But, some people, if you like pen and paper or a whiteboard, it's kind of cool to just, use whatever medium feels right for you to express these ideas. Maybe you take a photo of it with your phone and upload it to the solution that you're using for project management. But I definitely highly recommend at least getting these notes out there so that, again, it gives more context to people who could be reviewing your code, QAing your code, and also just allows you to get feedback, right? In general, sometimes if I'm going to be pushing a solution out, before I start writing code, it's a good idea to just review it with my peers on the team. Say, hey, here's my approach. How do you feel about this? You may get a perspective that you weren't expecting. So let's kind of take a look and think about, we're going to start with back-end architecture. So we'll just kind of like give a little title here. So, and we could kind of move from here forward. We got a little back-end architecture card here. Let's think about what this needs to do, right? We need to be able to fetch a list of articles and know if a user has bookmarked them. So how can we model this? Let's start with a naive approach here. And I'll give you a hint. This is likely not going to be our final solution, but I like to start with the idea that it is okay to be wrong or to not like the initial solution that you came up with. This is something we should feel quite comfortable with as engineers and get used to, because it's just a way of life. We're just thinking this is sort of a mode of expression. We're solving problems. So let's just kind of start, with the top here. we have this idea of bookmarks. A user is going to click on an article. Let's imagine we have an entity in our database, and this is the user. So we have a user in our database, and we obviously have some kind of an entity called an article. And I'm not going to specify, like, it doesn't really matter if these are documents in a NoSQL database or if these are rows in a table. You know, we just have a model for a user and an article, and we have this concept that a user is going to bookmark. So one approach here is we could simply have an object. You know, we have our user object, and this is probably the worst possible font to use for this, but we'll go ahead and let's just imagine we have bookmarks, and we could just store an array of bookmarks inside of our user table here. So we could have, you know, the article ID, right? Article ID, and it can be 1, let's say, and we'll, you know, now there's a few things we could do here, right? You could potentially store, you know, more, you know, article data, the rest of the article data. Let's just imagine, you know, we could actually store like the whole article under bookmarks in the user, which would allow us to do, you know, you may think like, oh, well, this is kind of interesting. Like I can, when I get down here or here, let's say this is the all bookmarks page, right? So like maybe we'll annotate that so it's a little bit easier to see what we're looking at here. All bookmarks. So in order to fetch all user bookmarks, this is pretty simple. I have a user object, it comes down, I fetch all the bookmarks, there they go. That makes that pretty easy. And then let's think about like here, this is sort of the all articles page. How would I do it here? Well, we have all our articles, and I guess for every single article, I have to go through this array of bookmarks and see if there are some of them matching. So, not super great. I mean, if there's only 6 articles, this is kind of an easy solution. If there's 10, 20, possibly even 100 articles, this solution isn't the worst in the world. User probably wouldn't feel something like that. But as you can tell, looping over these all the time, not has an icky feel to it. Let's just put it that way. And then, of course, in this case, we have the article page right here. And in this case, to find out if it's bookmarked, we simply have to, again, loop the array once, see if the article ID matches, and that's it. So we have a bit of looping here. We have a bit of looping. We effectively have to loop. It does make all bookmarks nice, but let's think about kind of some problems here. I guess article ID of 1 with the article data can make this rendering quicker, but it is a duplication of data. And generally, I probably wouldn't love the idea of using denormalized data in this specific situation. I would much prefer our bookmarks to be, you know, so let's like remove this. You know, we have like our article ID, and then this would just be a list of article IDs. So like 1, 2, 4, 8, 5, you know, I don't know, 8, whatever our IDs. These will usually be UIDs or something like that. And then we could go ahead and look up the article. So we could then simply have a, you know, this kind of keeps the data a little more compact on the user, right? You can imagine this is it doesn't scale super well, right? So we have a situation here where this is pretty easy to implement. We could implement this in code very, very quickly. We would have a working solution in front of a client right away before the end of the day. We're like, great, this is great. You know, here's your demo articles. You can see, you can add a bookmark, remove a bookmark. All it's doing is pushing and popping an ID off of this array. Quite simple. Where does this start to break down? So like, I guess we can list some pros to our approach, right? Like I like to kind of list out how I'm going to do it given this approach. So for all bookmarks, you just fetch the user, and then in this particular case, if we store whole object denormalized, right? You can write something like denormalized in there. For article, we can simply fetch, render the data right off the user. Now we come in and we're like, all right, that's kind of cool. Pretty simple. We fetch the user. We start. What's the pitfall for this? Well, the first pitfall right away is the minute we update, let's say we update any of the article data. If we update any of the article data, we have to go through every single user that references this object and update it, right? This works for things that this approach of storing the entire article object inside the user would be better suited for something that's truly immutable, that could never be edited. Imagine like maybe a customer is leaving a review or something of that nature that they weren't allowed to edit. But in this case, articles have updates. So like if we update an article, we have to update all of the duplicated objects under the user. So let's do this. I'm going to write kind of like what the option we're talking about here is, like option 1. Store article object with user. Very simple, yeah. Store bookmark article object fetch user gets us all data we need. If we store the whole object, we're in the denormalized state, which means we have duplicated data. But now we have to update all these duplicated objects under the user. This is effectively right here kind of my sticking point, I think. But we could take it just a little bit further here. On the all articles page and the article page, to identify bookmarks, we have to loop over all articles and identify if they are bookmarked. And so we could kind of leave a note here, this would not scale well to hundreds of bookmarks, right? So we start to get, if you imagine a system like Facebook, for instance, where you've been liking stuff for years, imagine something like Twitter where you can bookmark things. My Twitter bookmarks, I never delete bookmarks. They're kind of always there. Sometimes I barely even go back to them. You imagine we're building a system. Users could potentially bookmark a lot of stuff. So that can be a little bit tedious. Now let's do a second kind of wrinkle of this. I'm just going to throw like option 2 down over here. Let's just like scan it over. Option 2 is store bookmarked article ID with the user, right? We're not going to store the whole object. We're going to do this little approach right here that I show. This kind of gets us away from this denormalized. So we kind of have the same kind of issue here, but we fetch the user, gets us the IDs, then we have to go and create a way to fetch all of the articles. Right? Now we're not talking about REST versus GraphQL here. If it was REST, you'd have to make multiple calls to kind of fetch through the IDs. If sort of more traditional RESTful approach. Otherwise, if it was GraphQL, you still have to make the fetch, but it would be a slightly different query that would feel a little more ergonomic, and it could be done in a single network call. Now, if we store the whole the advantage here is do not have to worry about article updates because IDs are immutable, right? This is not going to change. if we update an article, we have to update all the duplicated objects under the user. This is no longer the case. Great. On the articles page, we have to identify bookmarks. We still have to do this, and this is still not going to scale well to hundreds of bookmarks, right? I mean, it scales slightly better in the sense that, you know, I guess it, depending on like certain types of databases, would allow you to paginate a situation like this, right? Especially once we start getting into like, if you had to show like 10 results and you wanted to do 10, 20, right? Or like some kind of lazy loading system. In most kind of modern databases, this is sort of not the greatest scenario for that, but it's doable, right? And this is like our option kind of 2 here, right? So again, what are the advantages of these options? They're simple, and they're quick to implement. You know, it really is. This really involves, right? I don't have to create any new entities. All I'm doing is adding a key to my user, especially if I'm in like a NoSQL situation. I don't even have to do much of anything here, and I store the bookmarks. I have some loop duplicate, like I have to loop and loop and loop and loop and loop. Not so great. Not such a big deal if someone's only got 10 or 20 bookmarks, right? So sometimes we don't want to prematurely optimize. However, I want to caveat this premature optimization because somebody could say, no, go with option 1. It's fast and easy, involves the least amount of changes to your existing database, and can get the job done. But here's the thing, like even when we remove, right? Like let's just add this too. To remove a bookmark, we have to loop the entire array. This is in both cases to find the removal. So we still have this situation where it's like, not so great, right? We're kind of like going through, but the cool thing is we're using our functional spec that we've sort of created, you know, over here to create sort of an outline of our plan for the database. So I can sit here and say, okay, this is pretty nice. I have to create some endpoints, right? So in both of these cases, let's see what's like, you know, I'm just going to add a little section here that's true for both of them. I need to create an endpoint to add a bookmark in some way, whether that, again, that can be GraphQL, REST, whatever you're doing, you need to create a way to add the bookmark. Need to create an endpoint to remove the bookmark. And that's likely kind of it, right? We add, we remove, but do I need to create new endpoints for that? Not really, right? I mean, really, this is no new endpoints really needed here, because this is sort of not necessarily. I have the user endpoint already. So I think another advantage to both of these is there's no need for this, right? So it's like, hey, I just use the user's endpoint. However we're updating users right now, I can do that. So I think the big advantage on both sides of this is just don't need an additional endpoint. So this is another kind of interesting way that this is shaping out, right? We're like, look, you know, and again, I know a bunch of you who are probably know the answer to why I'm not into this right now, this solution right now, are yelling that this is the wrong way to model it. But there is something to be said for, you know, if I'm sort of a more front-end focused engineer, I probably already have this user's endpoint. I don't necessarily need to do any back-end work to get this done at this stage of the project, right? Someone's already made an articles endpoint. Someone's already made a user's endpoint. If I'm in a NoSQL world, if I'm in a more relational database like Postgres, I probably will have to run a migration to add a column so that I can store bookmarks as an array and specify the type of data that I'm going to store there. Otherwise, this need to create bookmarks or even just update a query or resolver in a GraphQL world, so I'll add that kind of here, is not really something that I'm going to need for this solution. So this is kind of hinting now a little bit at the future here. I'm looking at this and I'm thinking the thing is, while this is very easy to implement, especially if we're on a NoSQL database where I'm not even going to touch the back end now, man, if I add let's see here, let's add a load more down here. This kind of gets complicated now because as I click this, I get a bunch more articles in. I have to go check the bookmarks again, right? Same thing now. How do I paginate this? Right? Let's imagine again, I'm going to have thousands of bookmarks over the years. So there's going to be a load more here. Now I have to paginate this subarray. And that's not so, now I got to, if I'm going to do that, I have to start digging into the back end more. And then this one again, super simple, not necessarily here, but the load more creates a situation where this is really not going to scale very well. So what can we do here? So I'll give a hint. Let's kind of take one of these entities and make some space here. So in the concept of this, we use FaunaDB here a lot, which is a NoSQL database, but also has relational modeling baked into it. And so you can do what's called a join table, or in this case, a join collection, or and use indexes to query. So let's start with that. Let's imagine we create another entity in here. And again, if this was Postgres, this would be another table. If we're in Mongo, this is going to be another collection. Just bear in mind that, especially with a lot of NoSQL databases, this type of modeling isn't always highly encouraged. Sometimes it's more of this style. So your database might dictate a little bit of how you're going to model this. For us, I'm going to go ahead and let you in on the secret that we're either using like Postgres or Fauna, and relational modeling is in fact encouraged. And I'll show you why this is a great and powerful concept in this case. So we create a bookmarks entity, table, whatever, and inside of here we have user ID, and that's going to be the user ID, some kind of UID, and underneath that, we have an article ID, and that's going to be, again, some kind of UID. We know that these are UIDs. So what do we have here? We actually have a completely new entity called Bookmarks, and it is a join between this entity and this entity. Kind of cool, right? So now I don't store bookmarks here at all. And what I can have, this user has an ID, which is some kind of UID, and a whole bunch of user data that is specific to the user. If a user bookmarks an article, I'm going to add a new entity to the bookmarks collection or table, new row, something like that. And it's going to have the user ID and the article ID. And then typically we will, in the case of something like Fauna, there will be an index that allows me to fetch the bookmarks by the user ID. And that'll allow me to kind of get to a place where, hey, we know these are the bookmarks that the user has. So for the all bookmarks page, this is actually fairly easy. I can now fetch bookmarks by user ID, and I can use and leverage my database to paginate these things, because databases can very easily paginate these results, especially when we're talking about a table or something like that. So that's kind of nice. How does this work? So let's think about this. For each article, we sort of end up in a little bit of a odd place. So this bookmark button effectively has to check for a bookmark that matches both the user ID and the article ID. And it just has to know if it's present. that's kind of simple. It's sort of like, hey, try to make this query. If it succeeds and we get a result, bookmark it. Try to make this query. If it succeeds and we get it, go ahead. This is what is kind of the downfall here, though? Yeah, we're not looping over an array, but we are making a lot more calls to our database to figure out if these are bookmarked. But it is something we can optimize, right? We can, instead of kind of letting the component try and like execute a call on the front end each and every time, we could potentially do some type of batch, right? Where we can kind of say, hey, of these articles, this user's requesting these articles, add a value that's, whether it's true or false, maybe bookmarked or not bookmarked, right? we can kind of craft that, but that we're getting a little bit away from database design, and that's going to be more of the back end of our application. But we're starting the wheels turning where we can see a pathway to making this more efficient with this design. And the load more works really nicely. Really good stuff here. And then for the article page, quite simply, we simply just say, can you, and again, fetching user ID, article ID, because we have the user ID, we have the article ID, making sure it's bookmarked, or we abstract that into our backend layer. So what kind of, for our option 3, so let's add a little color here and let's jot some of this down. Option 3. And again, we're just covering database design here. The interplay between the back end and the front end and optimizing these things, this is going to come as the next step. But we're completing the thought here. Use bookmarks table or collection as a join between users and articles. So we need to create some kind of endpoint, right? To add a bookmark, need to create an endpoint resolver. To remove the bookmark, we need a way, I guess you'd call this a, mutation, right? The same here, mutation. And then this is need to create an endpoint / resolver to get all bookmarks. And then we won't talk too much about the optimizations. However, let's just take a look to locate bookmarks on all articles page. We can simply, I don't like to use words, we can fetch bookmarks by article ID and user ID. If there is no result, the bookmark does not exist. We can paginate our bookmarks easily, leveraging the database, right? In this case, so we have easy pagination of bookmarks. It's actually a quick fetch, right? We don't have to fetch the user. Updates to the user and to the article do not require additional updates of the bookmark unless the article is actually deleted from the system, right? This is a key kind of caveat to think about, right? If we have to delete an article, we do have to remove that. However, it's much easier, right? However, it is simpler to remove the bookmarks because we can fetch by the article ID. And we could perform this potentially as a transaction, right? Where all of this must happen or nothing succeeds. Obviously, that's probably not the case here. If you had like tons and tons of bookmarks, possibly the best way to do this is this would kick off kind of like a queued job that could later delete the bookmark, so the article gets deleted right away, and then something else will run in the background to kind of comb the bookmarks table and remove everything. You wouldn't implement that right away, but it is optional. It's there. It scales a little bit better than our previous example here, where we'd have to go through all the users, then loop over, and then like if you had thousands of users, you'd be paginating over users for days. Option 1 and 2 really break down fast at scale. So while the rule of do not prematurely optimize doesn't necessarily mean don't think at all about optimization. It simply means don't go ahead and try to optimize for Facebook level scale. But this is a pretty low calorie way for us to build an optimization that we're pretty sure we're going to run into, right? We still want to think about it. We're not talking about a ton more time here. We're still in a pretty good place. I would not necessarily implement the idea of deleting all the bookmarks as a job, for instance. Initially, I would say when you delete the article, we'll delete the bookmarks at the same time. If that started to break down, we could add the optimization. But you can see that provides a lot of pathways. That's kind of the key. We have a lot of pathways to scale here. So we've sort of kind of laid out, this is kind of roughly like, again, a lot of this is happening in your head. You're kind of thinking about these kind of what you're going to need to create it. What are the pros? What are the cons? It doesn't, this is for you. So now that I've showed this is kind of what we're looking at, right? We're going to go with something like this, and let's kind of go back over here to our back-end architecture, and let's just let's rename this a little bit. But yeah, this is probably more a database than purely kind of, we're not necessarily talking about the entirety right now. So I just kind of like, again, like I was saying before, you throw a sketch in here, you say, hey, what's going to go on? What am I going to do? Well, we're going to create a bookmarks collection. So I'll let you in on a little secret. This is a NoSQL database. In this specific case that we're thinking of, I'm using FaunaDB, so I'm going to kind of use that terminology, but you could use the idea of table or what have you. So we're going to create a bookmarks collection. We're going to create an index to fetch bookmarks by user ID. And we're going to create an index to fetch bookmarks by article ID. And we're going to create an index to fetch bookmarks by user ID and article ID. Because each of these bookmarks too, it's worth noting, they will also have their own primary key. Right, so bookmarks is going to have its own ID on its own there. Cool. So this is kind of how we're going to lay out the database, and then we could kind of lay out what the plan is, around this. We sort of know that this is going to require at least these steps, and then we could kind of just jot out how we're going to do this. And this is really for our fellow developers to kind of know what we're planning. So for the, and again, freehand running for the all articles page, we will fetch all bookmarks that match. We will, hang on, let's see, attempt, right? Attempt to fetch all bookmarks that match the article IDs displayed. When paginating over articles, we will attempt the fetch with the new page of articles. For articles that have a bookmark that match the article IDs displayed and the user ID making the request. That's an important distinction there. User ID obtained by session token, right? Something like that. You can use the token to get to who is this user, right? That's sort of what would end up happening here. You could also pass the user ID if you had it kind of in like a global state. In this particular case, the session token kind of gets passed over with every request, so I would just use that to get to my user. That's just me. And then again, when paginating over articles, we'll attempt to fetch the new page of articles as in the above bullet. For articles that have a bookmark, we will serve. What will we do here? So this is kind of an interesting distinction because we're starting to get into how we're going to design this. Are we going to fetch articles and then the bookmarks data will come back with it naturally? Or are we going to fetch the articles and then kind of have to fetch bookmarks separately and then bridge these together on the front end? For me, I'm going to bias towards the lesser of the network calls. So we're kind of getting into how my plan for the API design. So what I would think is, this is how I would start to think about this working, is for articles that have a bookmark, we will send back a bookmarked key that tells us if the user has bookmarked this article, right? Not going to specify what that key could necessarily be named. We'll send back a key with the article has bookmarked this article. The user has bookmarked this article. Let's just drop that down there. Cool. So this is kind of like our all articles plan. Let's kind of go down into the bookmarks page. For the bookmarks page, we will fetch all bookmarks by user ID and article ID. Will obtain user ID from token, right? Same thing. We don't necessarily need to pass the ID back. We may ruminate on that. We'll come back to it, right? It does require like another fetch versus if I had the ID already as like a part of my context, I wouldn't have to do the token lookup. So it could save us a little bit of time there. Again, minor optimizations, not necessary for this stage of the architecture. Remember, we're just trying to get the broad strokes out, and to kind of present it to our team here. And then we'll then fetch articles by the article IDs received from the bookmarks. And again, if with Fauna, as with if you had Postgres, you can actually make all of this happen in like a single SQL call. If you're using some kind of an ORM, if this was like Ruby on Rails or something like that, there's like an includes directive that will allow you to join the two collections. So it's not like you have to make like multiple API calls to make this happen. In a purely RESTful, like in a real purely RESTful API, you may have needed to do that. You would get like an ID, an array of bookmark IDs and kind of have to fetch in that section. But you don't have to here. To paginate bookmarks will fetch next batch the same way. So pagination works much like you would imagine it working. Pretty simple there. and then kind of going into the on an article page will check to see if there is a bookmark for that article ID and user ID pair. Super simple, right? So here we are. We have a little bit of back-end database design. We did not dig too much into the implementation details of this yet. We have a plan now, though. We sort of know, okay, these are the things I need to add to my database to make this happen. This is roughly how I'm going to make this happen on the All Articles page. This is roughly how I'm going to make this happen on the Bookmarks page. And then this is roughly how I'm going to make this happen on the article page. For me, this is usually stuff I'm doing on pen and paper. I'm kind of drawing little diagrams. Usually the problem as it grows in complexity, this is it's a little less cut and dry than this, like, hey, option 1 and 2 that really clearly don't scale versus option 3, which is a little bit more scalable and is a little bit more of a classical and obvious choice. But I think you get the picture here, that we're just trying to jot our thoughts out, weigh some options against one another. And once again, we have not written any code yet. We have not put anything down. We have not created a pull request. We're not mad at our fellow developer that saw us open a pull request up for option 1 and go, oh my God, this is absolutely not going to make it past the first week of the project because they plan on having 20,000 users on there and 50 million bookmarks. It's great to weigh the options. And on top of that, you can now send this off to your fellow developers and say, hey, I've been tasked with this bookmark feature. I'm going to leave a comment in here and talk about my plan, and this is sort of the plan to kind of execute this. And it also makes it easier if you're kind of working on a point system or something like that. We weigh in, we agree on this approach. It's actually a lot easier for me to actually say what the complexity is based on the current application with a bit of an outline as to what someone's thinking and if there are any problems with this plan. So that's going to be part 2 here of mapping our database architecture and backend and getting prepared for the next phase, which is we're going to actually implement this feature or not. We're effectively going to kind of work through some implementation details, I should say. We're going to get into the weeds and finish up the back end here. See you soon.